So almost all trials of this lab includes finding the velocities of these
We
two
changed the
graphs.
lab, didn't we?
We changed the lab.
Oh,
So
yeah.
I have the wrong one posted.
Oh, okay. So to find the velocity, formula is same. Del L by del S and del T. So here that length is the length of this paper.
Okay.
This is the length. And since this photo gate is in the gate setting, so what it does is when this end just crosses the light over here, the timer starts, and when it passes from this end, the timer stops.
Okay.
So it measures what time it takes to pass through this length. So this way we can find the velocity. Now, one of the cases where we want to find or verify the conservation of linear momentum, what we do is, let's take this as a elastic collision. This has magnet, this has magnet on the same polarity, so it will repel without touching. So, and another thing is, students should be, they also need to take the video.
Okay.
Because this time frame is pretty small, they may not notice that difference. So let me reset. So let's take this at rest. V2 is at rest. I will move this. Yeah. What they need to do is they need to take a video of this timer, because when it goes this way, it will have let's say T1, the time difference when it passed through this length, and when it comes back again, that will start from the same time. It will continue. So they need to track that time.
Right.
What time it took to go through and what time it took to go back. So we can do it again, for example. Yep. So, and actually this is the only thing that you need to know in this lab. This is the simplest lab you can do.
Okay.
The only thing is you just need two photo gates, and another case is when it goes through, you need to find the time for this one as well. The length is fixed, only the time that it takes to go through that length. And then you have V1, you have V2 masses. You can just measure the mass of these two cars and verify that the momentum before collision and after collision are conserved.
Okay.
That's it.
So we have to keep this red car constant at whole experiment.
No.
During whole experiment. Or?
No. In one of the trial, you need to we measure the velocities for both. Okay, we do that for both. So let's go. Can we get the manual on the board?
Yeah.
Let's do the whole trial, right?
Okay.
Whole trial.
So the previous lab, or the lab that we were gonna do for this week, was too difficult or too complicated.
The previous lab was, yes, yeah. Actually, that lab was also, updated.
Yeah.
When I did maybe 2-3 semesters back, that was also updated,
Okay.
and it was far easier. Maybe next semester we can put the same. I thought all the labs were updated, but no, they have given Matt the old version of all those labs.
It's always the higher ups. it's like the higher ups give Matt this, Matt gives us this, we give the students this, and then we're the ones to look like, oh, you guys don't know physics. It's like, oh, we got 90% like error.
Exactly.
Okay, I think it's up.
Let's go to the first part. Okay, with no mass on either card. Okay. Okay, with no mass, I hope both the cards have the same mass. So with no mass means same mass on both the cards, right?
Yeah.
Right, it's no mass. What is that?
Blue
Okay.
card, I think blue card is weightless than red card.
This one is heavier, right?
Yeah.
Anyway, the thing is we should take both the card to be of same mass. Okay, send the first card through the first photo gate by giving it a slight soap. Make sure the cards are aligned such that their magnetized sides are facing each other to bounce off each other. Record the time for photo gate 1. The time it took card 1 to go through the gate as time 1. And the table call once the collision occurs, the second card should go then through the second gate. Record the total time. Note this has the potential to happen quickly. It is recommended that someone take a picture of their cell phone. Okay, so it is close. Okay, now so the thing is after it just passes, okay, it touches this one, that's okay. Okay, so it's a little far. It says one to hold, right? It
I don't
says-
think on this one.
Oh, no, okay.
I think it's trial 3 I was looking at says to hold.
Oh, okay. Okay. So, and what it says, record your times in the table below and use the length of the gates to calculate the velocities. This is for V1 and both V2. Okay. So let me push it. It says it's put it in the gate feature, right? Does it say somewhere? Can you scroll up? Let's see.
Why not?
It should be in the gate feature as far as I remember. Yeah, okay.
Yeah, it should be on gate setting.
The photo gate timer should be on the gate setting, and you should verify the timer works while the flag cuts beam and stop beams are not gone. The timer gets started, the timer second also. Okay. Students should verify that when the timer on one gate stops, the timer on the second gate also starts when the second photo gate beam is cut. Okay, let's check that. No, right? We have time for this one, but we don't have time for this one. Is it connected?
Yeah, it was. I mean, it was reading before when you were moving it back and forth. Like
Let me see. No.
when if you reset it, I think then it.
Reset.
See when you reset it. It reads a time for that. It's just not reading a second time.
Okay, let's do one thing. Okay. Oh, okay.
Okay.
Now, okay.
What did you do?
Memory on off.
Was it just?
That's why the students would need to take that
Right,
video.
right, right,
Okay.
right.
So let's do that again. Yeah.
Okay.
Right.
So, D1, D2.
Yep. This length is same. You don't have to measure the length every time. Length is same. T1 is the time it took to, and
Collide.
also collide. And also the thing is, this is the time before, right? Before collision, and before collision, this is at rest. V1 is 0. For this one, V2 is 0. We have the V1, right? And we can find the final velocity after collision for this car as well because of the time over here. And what about the, since the masses are same, it will stop.
Right.
Wow.
Okay, first part done. Now let's go to the second part.
Yeah, I was noticing that looks like it goes from trial 1 to trial 3. I don't see a trial 2.
Oh, okay.
Really? Oh. Okay. Well.
Oh, no, trial 1 and 2 are on the table.
Yeah, but
Oh,
it doesn't tell
okay.
you what to do for trial 2.
So just add 250 gram mass on the board.
Yeah. Like down here.
Okay.
Just trying to see with a different mass.
Yeah.
Okay. So we already did that. We already did
Yeah.
trial 2
very
basically.
good. Yeah, actually.
So.
Yeah, and they're still both equal mass.
Yeah. So.
Now,
Okay.
hold card 2 is stationary with a hand. Okay. Stationary with a hand. Send second card through the photo gate toward card 2. Record the initial time it took, as well as determine the time it took for it to rebound the card. Record the initial, final, Okay. Start. Yep. And it was actually, it should be very gentle. So let me try to be gentle. And students should actually, put something heavy over here so that this does not move, or maybe some blocking over here.
Just gonna make sure you
Yeah.
give yourself enough
And we
room,
have both the
but-
time here, right?
Okay.
When it was going in this direction, let's do that again. So, yeah,
Okay.
let me make it a little farther. Yep, both the
Okay.
time. So we have V1 and V1I and V1F, both. Velocities for this one, that's 0. Again, we will see that equal, but in opposite directions. Also, students should be very careful about the sign of the velocity as well.
Yeah.
Mhm. They need to specify that, not only the magnitude, but also the signs. Let's go to trial 4. Oh, I think trial 4 is also in
Yeah.
the same table.
Go.
Thank you.
No. Now inelastic case. Now flip the. Wait.
Wait.
It's okay.
Wait.
Now flip the cards such that their Velcro sides are facing each other.
Car facing each other.
Velcro
Wow.
side. This Velcro
Mhm.
side is facing each other.
Mm-hmm.
That means it should stick together
Yeah.
after the collision. Yep. No.
I was gonna say, I feel like that's in the way, right?
Yeah. So there should be some way to. Oh.
Wait.
here we go.
Okay.
Wow.
Yeah. Okay. So. First trial, perform the same type of procedure as above. The first trial with both cards and no extra mass. Okay, same thing. Now repeat it. The thing is, this is now inelastic collision. So this is at rest. So V2I is 0. We can calculate the initial velocity of this card when it goes through this gate, right? And we can find the final velocities for both the card when this passes through this gate. So, yep.
Okay.
And only thing is, we should take the time for only this part, right?
Yeah.
That's the, yeah, that's the.
So that's why people, should, record it to get the time when
Yeah.
this goes through.
Yeah.
Okay.
Yeah. Mm-hmm.
Let's go matter length.
Oh.
The length, we should take length for this one.
This one. Mm-hmm.
Okay.
So, and you should do the same thing with a different mass on both the card.
Okay.
So,
Different mass on both cards.
both cards. Yeah.
So second time.
Yeah, it's got 5 trials of inelastic with different mass combinations.
Like that.
So we are given only 2 mass.
You mean,
Yes,
no, you
but
can.
that's all you need.
Yeah.
Because it never goes above 500 grams added total between the 2 parts.
Okay. If you need extra mass, then we can add mass on top of it.
Wow.
Okay.
Yeah, but just, yeah.
Now, any other cases?
No. Cases. In table M1.
Yeah, for different masses, and now the questions.
No
Okay.
edit mass. No edit mass.
So one thing, what I love to do in this class that
Yeah.
I will show you here. Okay.
Wow.
Okay.
Okay. These 2 equations, right? Linear momentum and kinetic energy. So these 2, from these 2 relations, we can derive the velocities, final velocities after the collision for both the object. If it was inelastic, then we cannot derive these equalities. Right? We can approximate that. We can use coding to
Yeah.
to do the things, but we cannot find these equalities.
That is beyond the scope of this class.
Yeah, exactly. Beyond the scope of this class. So these are the formulas. Now let's take any 2 object where you just want to simplify these equations. Okay. To simplify it, let's take this second object is at rest initially. So this is, we don't need this, right? If the second object is at rest, V2I is 0. This is 0.
Yep.
So we don't need this. Now it is simplified more. Now let's take one of the case where M1 is very, very less than M2, which means 1 is, let's say, a stupid boy in scooter, right? 2 is, let's say, semi-truck.
Oh Jesus.
Yeah, it's
Poor boy, this is not going to go well.
yeah. Okay, so now, and this is at rest. Semi truck is parked somewhere on the road, and this guy is on the scooter. Okay, this stupid guy. So what will happen? Just you can ask the students about their intuition. What will happen if a boy on a scooter just collide with a parked semi truck? They will, by intuitively they will say that, oh, he should bounce back, right? They may not say that with the same velocity, but they will at least say that he will bounce back. So let's play with the equation. So V1F, which is the final velocity of that boy, right? M1 is very small compared to M2, so we can neglect this M1. So it would be minus M2 divided by M2 V1I, which will give us V1I. it will bounce back with the same velocity. Whereas V2F, you can ask what will happen to the truck. Will it move? Then they will again say that no, it should not. And they will see the same. We can neglect this M1. It's very small compared to M1 plus M2. So that means it's something like 0 divided by something, right? So 0. 0. It was already at rest and it will continue to remain at rest. Now second guess. What if M1 is far greater than M2? And in this case, what we are doing, yeah, 1 is semi-truck and 2 is that stupid boy in the scooter. Okay. Now we have assumed that our V2I is 0. So this boy is at rest. So what it did was, he was riding the scooter, all of a sudden he climbed the ramp. Okay. He went through the ramp and then as soon as he got to the expressway there. So semi-truck with 70 miles per hour, bang. Now you can imagine what will happen to the speed of that truck.
Nothing.
Will it change? Nothing. So let's see whether it will. V1F, which is our truck. M1 is very massive, so I can ignore that M2. M1 divided by M1, V1I, which is obvious thing, right? With the same velocity. Now V2F, what will happen to the?
I pushed it and then that shot out and it all just like flung back.
Okay.
Was not supposed to happen.
So what will happen to that boy? What will be the speed of that boy? Will it be the speed of the truck, 70 miles per hour?
Yeah.
At least, right? So let's see, according to this equation.
Yeah.
2 M1, M1 is very heavy, divided by M1, I can ignore that M2. V1I, it is actually twice the velocity of that semi-truck.
Because the change in direction.
Yes, exactly. So it will just, that boy will just fly off.